Okay, now sort of the finale of the continued fractions.
Oh yes.
How they solved Pell's equation.
Long awaited. Oh yes.
Maybe just
long awaited.
a quick recap of stuff. And now I think about it, maybe I can just give you the recap, and then you can tell me how the proof goes, because essentially, you know, like it's kind of a bit of a chase. Okay, remember what continued fractions were?
Yes.
It was like
A1.
we had like A1 plus 1 over
A2 plus 1 over. Proof by definition.
Okay, and then the way we wrote that
He
was
forgot.
A1. Oh yeah, did you watch the video?
He forgot.
Yeah, add the details everything you watch this.
Why am I writing 4 there?
Wait. Oh no.
Oh god, the dot dot dot.
The dot is not.
Okay. And then we had stuff like, remember this? Pn over Qn equals A1 to An, yeah? And this also shows that they're co-prime. Pn Qn minus 1 minus... So I feel like I might have gotten the sign wrong here, but... And the PNs can be calculated like this.
Pn Qn minus 1 minus P.
So it's not like I'm expecting you to like
understand.
This is just a review of previously. So just remember these as facts. But so even though they're not proven here, it's kind of obvious what their role is, right? They give you a direct way to get the P's and Q's without getting the whole fraction. And remember, this was also another way to solve the Bezout's lemma.
Oh yes.
Because you get something of the form ax plus by equals 1 when n is even.
Yes.
Okay, so slightly more complicated than this here is if instead of taking the tail, like so you can also take this to be like, for example, A1 plus 1 on A2 plus 1 on, and then this is sort of just the same thing as A3 onwards, right? So you could potentially write this as A1, A2, A3, yeah? And then it's finite, yeah?
Yeah.
So
purely periodic.
So in some sense you could write your alphas you can write it as so I mean you don't have to do it at 3, you could do it at n, right? You can write your alpha as sort of the very last Pn over Qn, where see
of the sequence.
you can write it as alpha n Pn minus 1 plus Pn minus 2 over alpha n Qn minus 1 plus Qn minus 2. Yeah.
Is A the same as alphas?
Oh, so alpha is like the tail.
Hey, what tail?
So if you write alpha as equal to a1 all the way up to an minus 1,
Alright.
alpha n, like that.
Yeah.
Oh, wait.
Repeat.
Yeah.
Yeah.
Okay. we're starting to get somewhere now. Really hope I haven't forgotten anything. But the thing that we learned about square root of n, you remember this? So this is the result that hopefully we'll watch on recording.
So alpha n is irrational, or
Yeah, most likely. Yeah. So if you have the square root of n, right? Its continued fraction. It's basically periodic except for the first term. Okay. So we had this theorem where, like, if something's purely periodic, then it's like it's a reduced quadratic irrational. Remember that? Like it's a
Oh yes.
and basically square root of
That's not
n.
pure.
Like the condition for reduced quadratic irrational was easy to test. Like you just test it's greater than 1 and its conjugate is less between and then which you can just do by adding something to root n. So adding something one integer just affects the first term of the continued fraction, and then it's purely periodic then. So once you subtract it, it's only the first term is not periodic. So it's something like this: a1, and then the a2 is what gets periodic. Yeah. How do we express this before? So it was like a3. You get basically up to halfway, and then at the end it's 2a1, and it goes back to a2, a3. It's like a palindrome.
wait, what's that?
Yeah, seriously.
Oh, no, I think I've seen it. Actually, no, I have seen this.
Yes.
Alright.
I will believe.
I choose to be.
Wait, could it?
Yeah, I'm pretty sure we only need this. I don't think we need to know the
Oh,
reduced
is it
quadratic.
odd or is it odd or even number in the palindrome, or is it?
Could be either.
Because would you have, if it's an odd number, then there'll be one number that doesn't repeat.
Mm.
Probably could be either.
Mm. Yeah, like when it's square root of 2, it's an odd number, right?
It's just one.
Square root of 2.
Okay. So maybe I'll write the others just in case. So it's a continued fraction is purely periodic, so that means it's basically the same numbers repeating over and over again. So for example, alpha equals like 1, 2, and it just keeps repeating. Yeah? If and only if it's a reduced quadratic.
Yes.
I still don't know what a reduced quadratic is.
That's all good.
Still,
Didn't we have this discussion?
yeah.
Okay.
Well, let's just hope you don't need to know. Okay.
1, 2, 1, 2.
Because we kind of used it to prove that the root n has this. And for Pell's equation, hopefully we only just need root n, right? So what is Pell's equation? Pell's equation is x squared minus ny squared equals 1, right? So how do we solve this equation? So basically the goal right now is just to find any solution, and then I'll explain how to get all the other solutions.
X plus 1 by I don't know what a reduced probability is.
Stop dwelling on.
I need to understand everything. Maybe a 5
Convey flashbacks.
Like, but you don't need to know how the atoms of my pen work.
Yes, we do.
Yes, we do.
No.
Explain to us.
We need to know
You need to know the concept
the concept of a mechanical.
It's broken bay flashbacks. Everyone.
broken bake.
B.
Curse things up.
Yeah, so I guess there's two ways to go, right? You can start from here and go this way, or you can start from this stuff and go that way.
Okay. So the alpha n. Is alpha n approach 0? No, wait, no, no, it doesn't. Wait. Alpha.
The alpha n approaches
The alpha n could just be a random thing.
yes, but there's certain good choices of alpha n, right? No.
Alpha n. The alpha n is approximately an. Okay, so the alpha n is greater. Alpha n is greater than an. Wait, alpha.
Alpha equals 1 on alpha equals 1 on alpha squared. Alpha times alpha 5. Alpha times 5.
Alpha. So what exactly is we doing? Everyone's quiet.
No, I'm just gonna read the book.
What?
Good choice. Yeah, but then I had a sign.
So you can never change someone's personality, even if it is weak.
There's something about like
Yeah. Okay. Well. So.
that only applies to the repeats. That is Russian.
Yeah.
Oh.
So the conjugate, the negative reciprocal of the conjugate is the reversed fraction. So if you have the conjugate and you took the negative reciprocal, you get the, it's like...
Oh, it's just a bunch of definitions.
Wait. Wait.
Okay, how about it? Root n equals alpha n pn minus 1 plus pn minus 2 on alpha n qn minus 1 plus qn minus 2. How about that? That's true, right? We just gotta pick a good alpha n.
Pick a good alpha. Wait, oh, I mean pick a good n.
Yeah.
Just pick it like at the start of the root.
Ah, pick it where the period starts, yeah?
Oh, so that would just bring alpha n equals to root n minus a1.
Plus a1? Minus? Oh, maybe, yeah.
Any minus here. Oh yes. Purely periodic.
Root n minus q1. Where did this come from?
Wait, n minus, that's a1.
A1.
Minus. minus A1, then it becomes interesting, that does become purely true.
It's what is it? Minus A1. Oh wait, oh that's the one. Oh that's when it's. Oh no, wait.
Oh, okay. So what's a natural thing to do here?
Also
Yes.
very natural.
Wait, what's
Oh man.
what's lowercase n equal?
Irrationals.
Maybe it just magically work. I'll never know. Yes.
Okay, what's lowercase n equal to?
Lowercase n.
Lowercase n is equal to what?
It's the one right after 2a1.
One right after two.
But that's 2 minus 1.
Actually, I'm slightly confused now.
Oh, so you define.
Oh yeah, hold on. Is root n minus a1? Does it have any a1s that repeat?
N minus A1 is just.
That's just
the
A2, A3.
Oh yeah.
Oh, no, it's 1 on the root. So it should be like 1 on. It should be 1 on root n.
Ah.
Like if you root n equals a1 plus 1 on a2 plus 4. So root n minus a1 equals 1 on root a2 plus 1 on a4. So 1 on root n minus a1 equals to a2 plus 1 on a3.
Nah. Maybe I am sick.
Probably not true.
N.
Alright, so the thing we're trying to think of here. So root n equals. So we want to make it a1, a2, root. So instead of repeating it, do a3, a3, a2, 2a1, right? And then we want alpha n here, is that right?
Because 1 on root n minus a1 equals to like root n plus a1 over n minus these.
Oh, so isn't this thing just this a2?
Yeah, that's just after
Yeah.
Right?
it's just the thing again. Yeah.
That's
So after you minus a1 to the other side, if it takes the show
So it's like
this is 1
on root n minus a1, which equals. Oh, I don't think we need to rationalize.
Oh wait, alpha n is equal to that again.
He's realized.
Yasser has a revelation.
Yes.
elevation.
Yeah, no, we're lagging.
Elevation.
He's
Okay, I
And
think I'm just lagging today.
doesn't he have COVID?
the lagging IRL.
He has COVID
He's
lag.
lagging IRL. Yes.
Okay, so you're saying it should be the reciprocal, alright?
Yeah.
Jeez.
Yeah.
That's how maybe.
Okay, let's persevere. Pn minus 1 plus Pn minus 2.
Yo.
Oh.
Multiply by root n.
8. Get root n. Yes, good. Initiative is good. Looks up. Initiative? Not detected. Scan. What am I doing? Alright, let's compare answers once we get to the end of this.
Yeah. Two.
Ugh.
Oh. Wow.
Okay. Now we have
Oh.
this
Two Q minus one. That'd be Q minus two.
Probably. Root Q n Q n minus 2 minus A1 Q n minus 2.
So,
select a like term.
what like terms are there? There are no like terms, man.
Try and do it in terms of n and root. I don't know if that helps at all.
Sound familiar. It's increasingly familiar. Oh. P minus 1 minus root n Q minus 1. Wait. Sucks. I see some recurrence thing. I see a recurrence thing with stuff.
I see some very, very anyway, I don't know if it's like idea. Imagine that root n is a variable. Apply quadratic form. Yeah!
Oh, big brain, yes.
Solve for root n. Solve for root. Okay.
Again.
I don't know if this is actually should be plus.
Oh yeah.
Yes.
This is cool.
This is looking it's slightly
There's like Pn minus 1 minus root n Qn minus 1. And then there's root n comes with Pn minus 2 minus root n Qn minus.
yeah.
And then
It's
take
a
A1
little
out,
bit
and then you get another P
too big.
Is that anything? The Pn minus. Oh no, they're all like some symmetry. Actually, quite a bit of symmetry. Quite a bit of symmetry.
Oh god, this is a very big. Oh, wait a second. But what? If it's wait, no.
Why is it?
The idea is you can maybe get nice things from this because this equals 2a1
Wait, are people
Because-
getting right one?
Oh yeah.
What?
Wait, no, it's true.
Yeah, are you on the whiteboard?
Yep.
I don't know.
I don't remember.
Wait,
I don't see anything.
Two.
We're not writing anything yet. We're kind of taking a pause to check if what we got so far is correct.
All right.
As just solving for root n. Top 10 smart. Top 10 smartest. Top 10 smart.
So root is 10. So what's the end goal of all this?
Good question. Good question. 2 p.m. I think this is Did you call it? Wait. No. It's root. What? What?
What?
You don't even.
Wait, what?
No. It's a key n. What? It's the trust.
The ultimate
Minus. Not a cube. Wait, it doesn't give you anything. You just factorize it.
Yeah, bro, you just-
anyway, you just refactor all the.
Wait.
You just factorize it.
Oh, no.
Don't worry. Yeah, it does.
Bro, you just.
You just go up the chain.
Wait, how does this work?
Like, oh no, this is.
Okay. What have you done, Leo?
That's the original thing, man. Basically.
Yeah, well, that's the whole.
Yes. Oh well, we got our first line and now we worked out.
This has to be.
This is.
It has to be some. I need to write it in. I'm writing it over.
Yeah.
Surely.
That's what I said to write.
Thing.
You did not listen.
You did not listen.
Non-listening weird.
Listen.
Leo, what have you done?
Glistening. Glistening. Glistening.
I hate this thing.
What's happening?
Wait a minute. Wait. That's just that just becomes a recurrence. That becomes fully recurrent.
Like a negative.
Yeah.
Yeah. Oh, negative of the purely periodic.
Wait, did you get something?
I kind of bashing. This bashing.
So are we writing?
Wait. Oh yeah, you divide them.
Yeah, that's what I'm
Yeah.
saying. Whoa.
Wait, this looks familiar. This
You
looks
did
really
not
familiar.
listen to Leo.
Like some recurrence thing of PN. Wait a minute. What's the recurrence of PN? What's
Wait.
Oh!
No. Wait, he has.
Wait,
It has to be good. Go with it.
You serious?
Yes, I'm going with it. Wait.
Oh, what? I think the recurrence was
Is
like
that the recurrence?
alpha equals alpha and like can you store alpha?
Yeah.
We need the formula. We need the
I think
cheat sheet.
we have deviated. We have different possible.
Yasseru's corner. We see there's a recurrence with the alpha.
Wait, I don't see what one you're
Oh my god, of course. Wait.
Hold on.
No.
Oh yeah. And oh
It's
that
around.
and he's
It's this thing, basically. It's this thing.
yeah, but it's the other way around.
Wait, no.
Yeah, I think
Oh, wait.
we could take a bit more care with the N the little n, and probably we could also make a different choice of. So we could
alpha n.
we can make a different choice of this. I guess.
It does not look quite right. Something's off.
Something's wrong. Wait, are we voting for weekend?
Multiply the top and bottom by.
Recursion is like separate.
Bro, that's just gonna create.
Create cancer.
Yeah, maybe just to streamline this a bit more. Can we pick an We can pick an alpha n such that root n equals, instead of root n minus a1, have root a plus a1.
It's gonna create. This is definitely not.
Wait, what's the purpose of like the
They're the fraction
Why
numerators
are
and
you
denominators.
choosing? Wait, why? How are you able to choose those alpha?
Wow.
It died.
What is Leon doing? Oh. What is Leon?
Hello, someone, anyone?
Oh,
Q&A. Stop going to KFC.
Hello,
Actually, maybe
I'm getting found out.
it shouldn't actually be n minus 1. It could even be n here. I think our n is already defined, so we have to be a bit careful here.
Someone, anyone? Hello. Wait.
It's in the floor, it's not there. Understand?
Alpha again.
Minus 1, yeah?
Wait, how are you allowed to choose what alpha is?
Okay, how does that work? So
what?
then we take. So there's already labels, right? So there's already. So 1. Huh? 1.
Because root n plus a1 is like a purely pure.
Oh. Yeah.
Yeah. Yeah, it is. Oh. Realizations. Realize it's 2a1.
Oh wait, that's so good. Wait, that's incredible.
People are realizing too many revelations at once. Wait, is that the same as this?
I think it's different. I think we got the little n's mixed up in the previous equation.
How do you reach that level of genius?
Because we went even further than this, right? And we put a smaller subscript.
Wait, how do you reach that?
This is
How do you reach
alpha,
that level?
like
Yeah, alpha n.
this is like alpha,
Wait.
like n or n minus 1 or something.
Oh yeah, that's alpha n minus. So shouldn't that be? Wait. Shouldn't that be like Pn minus 2?
Maybe I got the numbers a bit wrong. So if you have n numbers here, then this is alpha n minus n plus 1. Yeah.
Okay. So that's alpha n. Alpha. Like what's n?
Sorry. Yeah, this. I mean, this is something we're figuring out. So this part here is the sort of the first cycle, right? Maybe that's little n, yeah.
Yes.
And our thing starts here, so this is alpha n plus 1. Yeah.
But then the alpha one becomes.
So alpha 1 is just root n. Yeah.
Oh.
Alpha 1 is just.
The what? Alpha one is like the.
Alpha 1 is
Alpha 1 is equal to the whole thing.
Wait, isn't that what?
So this is equal to alpha 1.
Okay. Alright. Alrighty then.
Alpha n is just a trail.
Yeah.
Oh, it's like alpha.
See.
The alpha thing is just as if you stop there or whatever value that thing.
Yeah, okay, so let's go from here, okay? So for some reason this... I think the other way sort of still works too if we took the subscripts more carefully. But I'm still curious about whether this is fundamentally different or not. So if he times it out, you get n plus... So n qn plus a1
Yeah.
qn root n, yeah? Plus qn minus 1 root n equals 1pn root n plus a1pn plus pn minus 1. Okay. But I think no matter what, this next step, I think it doesn't change what the step is, it's just it probably changes what the answer you get is. So nqn, yeah, we got that, plus a1qn root n plus qn minus 1 root n equals a1pn plus pn minus 1 plus pn root n. Okay, so we're we're guaranteed to conclude this calculation.
Oh, the cheat sheets.
Wait
Yeah.
a minute.
Wait.
Sometimes it helps to keep things on schedule.
Necessary.
Michael doing
What?
nothing.
Oh. Well, I mean, the cheat sheet doesn't affect what you're doing. The steps are the same. You're just not going to be disappointed at the end. Okay, this step is taking a little bit too long. This is like one of the first proof exercises I gave people, maybe in your class, back in the day. It was like, show that anything can be written uniquely as a plus b root n
Oh, God.
for unique a and b. You remember that?
No.
So like, if you write something in the form a plus b root n, yeah? That's unique.
Oh. Yeah, you just like
Gal.
what n is not. Oh.
Because a minus c equals d minus b root n.
Yeah.
And then you get like otherwise you get like root n is rational unless the thing is not.
Have you guys seen this exercise?
Still,
Oh, n is you fix it. Oh, okay. In that case it's you.
Oh.
Because then a minus c and then root n d minus b implies d minus b. A minus c is rational. Then d minus b also has to be rational. Has to be irrational to cancel out the root n.
Yeah, so can you see what that means for us?
Wait. What?
Hold on.
How did that happen?
Oh, collect the n terms.
Oh.
Shift everything there.
Oh.
What the hell do you
Let's
do from
go.
there? No, you.
Wait.
Wait, is A1
Wait.
A1 is root n, right?
Wait, this is insane.
A1's just an integer.
Hold up. Okay, collect the terms then.
Collect root n term.
Collect root n terms.
Yeah, so you get n qn, right, equals a1 pn plus pn minus 1, yeah?
Oh, yeah.
Then you get
Oh, genius.
a1
Oh, look at
qn
that.
plus qn minus
Oh,
Whoa, that's
Oh.
insane. Damn.
this is ridiculous.
equals pn.
Oh,
Damn.
oh no.
This is like.
Wait, we saw pn is there.
Oh,
We saw
wait.
pn minus. Wait, we saw pn.
Wait, no.
This is not even.
Wait, no.
It's not that we could.
Like, explicitly. Well, what facts are there? I think that is find them with A1 Qn plus Qn minus 1 plus Qn more. And then n minus. Wait a minute. So that's the purely periodic.
Wait, what's on the whiteboard? There we go.
What's on the whiteboard?
Wait, what's Leo when people do writing on?
Nothing.
They're on a double. They're on a physical whiteboard.
We do plug in the physics.
Wait, when you say like Pn and Qn,
Pn into the first one.
Like, what are they the numerator and denominator of?
The finite portions of the continued fraction.
So you take it until NAN, like A1.
You stop at like an, and that's Pn over Qn.
And then everything is after that is like repeating.
No, everything's just not existent.
Or A.
So you do A1 plus 1 on A2 plus 1 on A3, which are like some finite AN. And that, since that's finite, that's rational. So you only go to P and Qn.
And then you do that like for each of them that's down.
Yeah, you can do that for each.
Yeah.
But why is it like rational? Why does the finite one?
Why does the finite one help?
Like, what does the finite one do?
Oh, I guess it converges the thing. It's like a loop. Anyone want a hint?
And what are we trying to find?
Trying to show. We're trying to show Pell's equation. So we got the n here.
Oh wait, what was it?
Thing equals 1.
Like A plus B.
Yeah, I guess here I'll put you on the list of previous facts. Yeah.
List the previous facts.
I might have to give this away in like a few minutes.
Oh wait.
So we could keep it going if you want.
What is going on?
A squared. I had A squared before. I'm going to sub in.
Okay.
Why is this so
A n squared. A n squared. Oh no, that's A. Wait, alpha in this case is root n. So a n root n. Yeah, that one.
Yeah, I guess we used alpha n plus 1.
Ooh. And Qn. Pn. Something. Around equation.
Okay.
Can you go back to the what we had before?
Okay.
The two things. Pn. Oh. So in this case, the alpha we had before is root n.
Yeah.
Yeah, and alpha n is like alpha 1.
Wait, alpha 1 is root n.
So this
is A1.
Oh, this is A1. Oh. Okay, so that's the alpha.
Okay, the thing about these two relations are that it nicely does not have any root n's, which you don't have at the end, right? Yeah, and it relates two n's to an n minus 1, you know? Linearly.
Yes.
Linearly is a closed form.
Closed recursion.
NQN.
Can we sub the P?
Oh yeah. Sub two sets of Pn, and then you can find a like closed form for Qn, and then you can do the same thing for like Pn, I guess. So like Q like NQN is equal to A1 squared Qn plus A1 Qn minus 1 plus can we sub in the
that's the
Right, maybe I can. If whoever wants a hint, you can look at the whiteboard. Oh, and also don't listen.
And don't get any.
Yeah.
I give up. Straight
And ignore me running into your page and writing the answer in the front of your book. So, this was the one that solved the other linear equation, yeah? I guess the thing that's good about this equation is it has a 1 in it, which Pell's equation has. Okay. So something has to equal 1, so 1 has to come from somewhere. This equation conveniently has a 1.
it's probably
And it's an equation with
Pn's and Qn's.
little n and little n minus 1.
Is it Lemma?
times the previous two.
Is it Lemma? Is it Lemma?
Lemma.
Is it Lemma?
So if we use this and go back to what we had before.
Take this knowledge.
Go back to the
Okay. So if we're assuming that one's written the right way,
so now we're gonna just like multiply some solid. So we want to multiply Pn with Qn minus 1.
I'm just going to solve by P. And you square this out by Q. Oh, you get nothing.
Wait a minute. Oh, if you times top equation by Q and bottom equation Pn, you get Pn
Hmm.
A1 Pn Qn, then you get A1 Pn Qn.
Oh, wait.
Oh,
I see. Yeah.
oh, wait,
Yes, that
wait.
works.
Yeah, yeah.
Right, you guys ready for a spoiler?
Oh, I think that's
Well
yeah.
done.
I think that's
Yeah.
Okay, so if you look at that equation, yeah,
oh.
the Bezout Lemma equation, yeah, it has a 1, sort of. It has a negative 1 or 1. It has little n's and little n minus 1, yeah? And what the bottom two equations have is they also have little n's and little n minus 1s, yeah? In particular, it has one little n minus 1 and two little n's, which means you can basically substitute n minus 1s out. Yeah.
I think I finally figured out what not what the equation before.
Yeah, so this might still be good to do yourself.
Yeah. It works. Oh, that's nice. Oh, that's nice. That's nice. Oh.
That's kind of insane.
It's absolutely genius.
Oh,
Yeah,
this is
it works.
kind of insane.
It works.
Oh,
No, this book was definitely worth investing.
Wait.
It works. Stop shit cancels, dude.
Shit cancels.
Shit cancels. Oh.
Yeah, not.
Oh my
Oh,
god.
shit.
How do you deal with it when
That's what.
Just take it easy.
just
What
say
is
N
this
zero. Too easy.
No, it says that it's not a solution if n is odd, right? It's saying that it's negative 1 if n is odd.
I was half asleep and then suddenly this happened.
How do you honestly?
Oh yeah, good question.
Gee. Actually.
It is old.
Yeah, good question. How do you do that?
Definitely end up.
What was n even? Do you remember?
Doesn't end.
The length.
Doesn't it
Long repeat.
Doesn't it not cycle? It repeats, right? So if it repeats, then surely within the next cycle, all ends will be.
Yeah.
Take N to 2N.
Isn't that how you generate?
Yeah.
That's likely how you generate.
Yeah, so Leo makes a good point. Okay, do you guys understand what his question is?
Yes.
So basically, the n is not like a free. It's not. We don't have this for all n. Yeah. At the moment, this is specific to n being the point at which it repeats, sort of that point, roughly that point. Yeah. So we don't have a choice. We don't have a control straight away over whether it's even or odd. So at the moment, if it happens to be odd, it looks like we're stuffed, right? But yeah, so maybe we could like have the period be a bit redundant. Is it possible to double have the A1, and instead of having the first part repeat, double the length and then repeat?
Yeah, I think that works as well. Like,
Yeah. So you just got to manipulate the period until the n is even somehow. Is that possible to do?
Period.
So for example, if root 2, right, is equal to 1, 2, yeah? So that seems like, wait, is that odd? What is n here?
N would normally just be 1.
Yeah.
So here n is n 2 here?
N can be 1, but you can just
can
make it
just
2.
like double the period.
Yeah, I guess. Yeah, you can make.
Double the period and then it works.
Yeah, one of these is gonna have different parity, right?
We know how to trick it now.
Surely.
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 Very
Wait,
surely.
N is the one right
Very
after
surely.
2A.
Very surely.
What is
Oh wait,
happening?
I think N is like
N
like
the first part,
here,
the
yeah.
lower would be
Oh.
So instead of taking 1, you can just take 1, 2.
Oh yeah, wait.
Wait, hello, someone.
Hold on.
Hello.
Yeah.
Yeah, it's like 2A, 1 right there.
Yeah. So
7. We just keep
so
on
in general
7 over 5.
you have A1. Okay. So A2, A3. So this part is N, right?
Yeah.
And then this part is root N plus A1, yeah? So if we just took this part, yeah, we
It
get,
has to be the same length as the first part. So.
and then we get this part is the root N plus A1, yeah?
Yes.
Okay. That's good. Yeah, I guess that's pretty good. That concludes the Pell's equations thing. So the book doesn't go on to how to generate the other solutions, but basically you just take powers of the minimal solution, if that makes sense. There's actually a few issues here. I might go over it again next time or something. But this is definitely a worthy point to stop. Have any questions about this?
Now,
Or a little bit
now we have 2 proofs. One is that the broken bay proof, and now we have this proof.
Yeah. Yeah, so a quick sketch of the all the other solutions. You take the minimal A and B that are solutions, and you make A plus B root N, right? And you can always take A and B to be positive.
Yeah.
And then all the other solutions, and you just take powers of this. Okay, and then write it in the form like x plus y root N, and the x and y are the solutions. Okay? So, yeah, and to show that they're the only solutions, you just suppose like there's some in between 2 powers, and then you divide out by the lower power. But maybe I'll do that next time. Yeah. In principle, you might have seen it before as well.
Yes. Twice.
Twice.